Breaking news shakes the scientific world. 3. I/Atlas, the latest interstellar visitor, has just veered off its predicted path. Now, its new trajectory targets Earth itself. NASA's models aren't showing a cosmic accident. The course change is so exact, it defies everything we know about natural space rocks. Experts call this a warning, not a coincidence, a threat aimed straight at us. If a 20-kilometer object traveling over 150,000 miles per hour has been steered towards our planet, what's behind the wheel, and how much time do we have left? The truth behind the sudden shift is only beginning to surface. Red flashes streak across the world's news feeds. Sirens blare, urgent headlines scroll. 3I/Atlas, once a distant curiosity, now dominates every screen. Emergency bulletins cut through the noise. Trajectory update, impact probability, planetary alert. Simulated shockwaves ripple over continents. Cities vanish in impact models. A digital countdown ticks down the seconds. Panic spreads in real time. Markets tumble, air traffic halts, military satellites pivot. The planet holds its breath, transfixed by the impossible. A cosmic visitor has changed course, and the next move is aimed at Earth. This is not a drill. The object now known as 3I/Atlas, only the third interstellar visitor ever detected, has altered its path in a way no natural body should. Discovered by the Atlas survey on July 1, 2025, its hyperbolic orbit once promised a harmless flyby. That promise just shattered. Every model, every alert, every expert now converges on one conclusion. 3I/Atlas is no longer just passing through. Its new trajectory draws a line straight toward Earth. The warning is clear. The countdown has begun. At NASA's Jet Propulsion Laboratory, analysts huddled over fresh plots from the Deep Space Network. For weeks, 3I/Atlas had traced a perfect arc, hyperbolic, indifferent, the classic signature of an interstellar wanderer. But then the data broke ranks. On the morning of August 19th, the residuals, the tiny differences between predicted and observed positions, jumped off the chart. The deviation was microscopic, less than 1/100th of a degree, but in orbital mechanics, that's the difference between a near miss and a direct hit. JPL's orbit-fitting algorithms, tuned to parse chaos from cosmic noise, flagged the event in red. No comet this massive should pivot so sharply, not without a visible cause. The team reran the astrometry, checked for instrumental drift, even called up the Minor Planet Center to cross-verify timestamps. The answer held, a clean 0.01 degree deflection, appearing almost instantaneously across independent observatories. In the language of celestial mechanics, this was a maneuver, not a meander. The standard explanations, outgassing, solar wind, the subtle push of sunlight, fell short by orders of magnitude. For a 20-kilometer wide nucleus, the required force was staggering, far beyond what any natural jet could provide. Monte Carlo simulations, millions of randomized trajectories, failed to reproduce the observed path unless they injected a burst of velocity, precise, surgical, and timed to the second. The JPL team, trained to distrust drama, found themselves staring at a residual plot that refused to be explained away. In the world of planetary defense, such a clean break from prediction is the statistical equivalent of a shout. Something, or someone, had changed the rules. TESS, NASA's exoplanet hunting sentinel, wasn't built to chase interstellar debris. Yet, on August 19th, its sensors caught something that shouldn't exist. A spike, brief as a blink, buried in the comet's light curve. The raw data flagged a 0.002 second surge, a flash so sharp it sliced through the background noise like a scalpel. Not a flicker, not a cosmic ray. The pipeline's cosmic ray filter, tuned to weed out false positives, passed this event with a confidence rating above 99.99%. The TESS analyst on shift, Dr. Leena Chowdhury, stared at the screen in silence. She'd spent years tracing the subtle wobbles of distant stars, but never seen a transient this clean, this isolated. The signal coincided, down to the second, with the moment 3I/Atlas veered off its predicted path. Natural outgassing is messy, unpredictable. It lingers, It smears across frames, it leaves chemical fingerprints in the spectrum. But the test flash was surgical. One pulse, then nothing. The energy required to budge a 20-kilometer-wide nucleus in open space is astronomical. For comparison, the Deep Impact mission fired a 370-kilogram copper slug at Comet Tempel 1 and produced a plume lasting minutes, not milliseconds. Here, the flash was over before most telescopes could blink. The data made its rounds, emailed, encrypted, dissected by teams from M1T to JPL. Some called it a glitch. Others whispered about propulsion. A few, off the record, used the word engine. No one could explain how a natural process could deliver that much force, that fast, with such precision. The question hung in the air. If this was a thrust, who or what lit the fuse? The European Space Agency's Near-Earth Object Coordination Center issued its first global simulation overnight. The results landed like a hammer. The uncertainty envelope of 3I/Atlas, once as wide as a planet, had contracted into a corridor just 150,000 kilometers wide, narrower than half the distance to the Moon, and Earth now sat squarely inside. In planetary defense circles, the phrase for this is Impact Corridor Overlay. It's the nightmare scenario. One shift, one nudge, and a world is inside the bullseye. The ESA modelers, usually stoic, sent encrypted updates to defense ministries and national observatories. Their simulation videos, looping in silent conference rooms, showed the comet's projected path slicing through the ecliptic, the blue marble of Earth caught in a red error band. For the analysts in charge of planetary defense, every hour now meant recalculating probabilities. Dr. Mireille Laurent, lead at France's CNES, described the corridor's sharpness as statistically surgical. No natural comet, no random outgassing, should be able to thread such a path. The object's trajectory, plotted against decades of impactor data, looked less like a wandering stone and more like a guided missile. Monte Carlo runs, hundreds of thousands of virtual comets, failed to reproduce the observed overlap unless they injected a precise, targeted velocity change. The odds weren't just long, they were vanishingly small, the kind that make even the most hardened risk analysts reach for their phones. The defense community's private channels lit up with questions. Was this an error in the orbital fit? A data artifact? Or something worse, intent? No one had answers. But the overlays didn't care about intent. They only cared about geometry. And on every screen, in every war room, that geometry now pointed at Earth. Inside Harvard's astrophysics department, the debate broke containment. Screens glowed with the latest orbital overlays, but the real drama played out in encrypted group chats and late-night Slack threads. Someone leaked a draft memo, stamped with the initials of a senior theorist warning, "Trajectory shift displays artificial characteristics. Probability of random outgassing insufficient. Recommend search for target acquisition signatures." The phrase, target acquisition, spread like a virus. It wasn't a slip. It was a challenge to the orthodoxy, a direct shot at the line between natural and engineered. Avi Loeb, already infamous for championing the alien probe hypothesis after Oumuamua, stepped into the storm. In a recorded faculty meeting, his voice was steady, almost weary. We have a responsibility to consider all possibilities, even the uncomfortable ones. The data are what they are. For some, Loeb was a prophet. For others, a provocateur. But the memo's language, clinical, cold, gave fuel to every conspiracy thread on the internet. Screenshots of the phrase artificial-looking trended in science forums, while mainstream outlets scrambled for comment. NASA, by contrast, retreated behind layers of protocol. The official press release called 3I/Atlas, an unprecedented anomaly. But the words were sanded smooth, stripped of alarm. No mention of steering, no hint of intent. Yet off the record, planetary defense analysts admitted the obvious. The maneuver, if real, was beyond any known natural process. In closed-door briefings, the phrase "steering can't be ruled out" hovered in the air, never written, always implied. The effect was electric. Public silence from NASA only deepened suspicion, while Harvard's leak fanned the flames of speculation. The world's top scientific institutions were now locked in a high-stakes information war, one side whispering about impossible physics, the other clinging to the comfort of precedent. The result? A vacuum of certainty, filled by rumor, fear, and the uneasy sense that something fundamental had changed. Hubble's ultraviolet spectrograph caught the first hint, a sharp, unnatural green flare blooming from the heart of 3I/Atlas. The emission lines cut clean across the spectrum, not the scattered glow of cometary gas, but a razor-edged spike at 557.7 nanometers. Oxygen, yes, but too intense, too sudden, too controlled. Spectroscopy teams at the European Southern Observatory triple-checked their calibrations, then flagged the anomaly. The profile matched not a comet, but a reactor. The phrase spread through encrypted science forums, reactor lines. Within hours, radar arrays on 3 continents pivoted to the inbound object. Deep Space Network dishes pinged the nucleus and returned something stranger still, a cluster of echoes, faint but regular, trailing the main body at exact intervals. Sub-100-meter companions, too small to be debris, too evenly spaced to be chance. The echoes repeated, frame after frame, as if these miniatures were locked in formation, following the mothership through the void. Dr. Michio Kaku called in for a late-night interview, didn't mince words. "We're not looking at random fragments," he said, voice low over the static. "We're looking at escorts. If this is a probe, those are its drones." Hubble's imaging pipeline, designed to filter cosmic rays and background noise, now flagged the green glow as persistent, pulsing in sync with the object's rotation. Each flare coincided with a subtle tightening of the companion formation. On the ground, radar techs mapped the dance. Each small body shifted position, as if responding to a central command. The evidence piled up: reactor lines, mini-probes, synchronized maneuvers. Not fragments, not random. The stack of physical clues left planetary defense teams with a single, uncomfortable possibility. 3. I/Atlas was behaving less like a comet, and more like a ship on approach, with its own fleet in tow. Orbital dynamicists trained to untangle chaos from cosmic choreography now face a pattern that defies every expectation. The path of 3I/Atlas no longer resembles a comet's careless drift. Instead, it traces a sequence of intercepts, each shift in its course aligning with Earth's future position, not its present. When the latest datasets were run through Monte Carlo simulations, millions of possible futures, each one spun from the raw uncertainty of astrometric measurements. The result was a statistical spectre. Out of 10 million randomized trials, fewer than 1,000 produced a trajectory that would intersect Earth's orbit at the right time. That's a probability below 1/100th of 1%. For reference, that's like a dart thrown blindfolded across a stadium, hitting a coin spinning on the 50-yard line. Dr. Michio Kaku, called in for a late-night segment, didn't reach for comfort. This isn't a scattershot, this is a precision intercept. The path bends, the formation tightens, and every adjustment puts us more squarely in the crosshairs. He pointed to the overlays: Earth's blue arc, the object's red line, the corridor narrowing with each new observation. The phrase targeting solution migrated from military jargon to planetary science. The pattern is too exact, the timing too deliberate. Each maneuver, each course correction threads the object closer to Earth's orbital path. The probability isn't just low, it's cosmic precision bordering on intent. Dynamicists, usually allergic to speculation, now whisper about strike theory. The evidence stacks: a sudden course bend, a pulse of energy, a reactor's green glow, mini-probes in lockstep, all converging on a single, chilling hypothesis. This is not a flyby. This is not a brush with cosmic coincidence. If the numbers hold, 3I/Atlas is on an intercept vector, and Earth is the target. The only question left is motive. Twitter's trending bar ignites with a single phrase: #DoomsdayRock. The hashtag surges past 10 million mentions in under an hour, outpacing every global news event since the start of the decade. TikTok loops impact animations, each clip more dire than the last. Fireballs, tidal waves, countdown clocks. Discord servers overflow with frantic theories, while Reddit's front page is a wall of speculation, memes, and grainy overlays of 3i/Atlas's path. Google's search traffic for interstellar impact spikes to record highs. On Instagram, influencers post tearful stories, some promising to live stream the end, others hawking survival kits. Telegram channels push leaked government warnings, fueling a feedback loop of fear. #analysts trace the surge. Posts double every 6 minutes, then every 3, as the world's attention narrows to a single cosmic threat. Panic buying erupts in cities from Seoul to Sao Paulo, empty shelves, gridlocked highways, rumors of martial law. Scientists try to inject calm, but their statements are buried beneath a digital avalanche. The world's collective pulse sinks to the rhythm of shares, likes, and retweets. In the chaos, one fact stands out. The line between science and rumor has vanished, and the planet is now a single anxious audience waiting for the next update. Pulse, glow, shift. 3 anomalies, each more impossible than the last. The world has watched them unfold in real time. A flash of energy, a reactor's green flare, a trajectory that bends with surgical precision. Now, every model points to a single outcome. Earth stands in the path. The countdown ticks, steady as a heartbeat in the dark. 3. I/Atlas has drawn its line. The question is no longer why, or even how, it's when. 3. I/Atlas was first detected by the Atlas survey on July 1st, 2025, and quickly identified as only the 3rd known interstellar object to enter our solar system. Astrometric records and rapid NASA modeling confirmed a sudden, precise shift in its trajectory, an event that existing natural models could not explain. High-speed photometric flashes, a reactor-like green emission, and the detection of small, coordinated companion objects added to the mounting evidence of artificial control. Internal documents from Harvard described the movement as target acquisition, while NASA briefings admitted that steering could not be ruled out. Yet, despite extensive international monitoring, no agency has released definitive proof about the object's origin or intent. What remains undisputed is that updated orbital overlays now place Earth directly in the impact corridor. As global headlines and classified analyses converge, one fact stands above all. 3i/Atlas has changed course, and every available model shows Earth is now in its path. The world waits for answers that, so far, remain just out of reach.